Hi there, and welcome to the Creating an API and Returning Resources module from the Build Various Types of Middleware. One of these is the ASP Net Core Mvc Middleware, which we'll need to build our API. Once we've got that up and running, we'll learn how to return data, or to use the more correct terminology, resources from our API, and how to interact with that API by sending HTTP requests. We'll also learn how we can configure the format of the response that's sent back to the consumer of the API. That's quite a lot of content coming up in this module, so let's dive in. What do we need to start building an API? Well, we know from the previous module that we're going to have to add some middleware to the HTTP request pipeline in the configure method, and that we'll have to add the framework services to the container in the configure services method. If we take one step back to the previous version, those of you who've worked with that will know that when building HTTP services, we choose Web API. And to build a client-facing web application, views and all, we choose ASP.NET Mvc. This has changed. In ASP.NET Core, there is no separate Web API framework anymore. The old ASP.NET Mvc and Web API functionalities are now unified in one framework, ASP.NET Core Mvc. It's positioned as a rich framework for building web apps and APIs using the model view controller design pattern. This makes sense. After all, Mvc is a design pattern that was used both by ASP.NET Mvc and ASP.NET Web API. The middleware we'll have to configure and add to the pipeline is thus the ASP.NET Core Mvc middleware. Let's clarify the Mvc pattern. Mvc is an acronym and it stands for Model View Controller. Looking at the definition, it's an architectural software pattern for implementing user interfaces. There's some confusion on what it exactly is and does, because different interpretations on what it should be exist. Essentially though, it's meant to encourage loose coupling and separation of concerns, which in turn allows better testability of your application and the ability to reuse parts of it. Mind you, it isn't the full application architecture. In a typical N-tier architecture, presentation layer, business layer, data access layer, more often than not with a service layer in between, Mvc is used in the presentation layer. And that's about it. Hence, the implementing user interfaces part of the definition. If you've ever worked with Angular, well, in some regard, you could see that as a client-side Mvc implementation. It consists of three parts. The model handles the logic for your application data. A model in this sense can contain code to retrieve or store data at that level. In some implementations, often when the Mvc pattern is only used at the top level of your architecture, the model doesn't contain any logic at all. It's another component of your application that handles this. For example, the business layer. In other implementations, a view model, which does contain code to retrieve or store data, is in fact used as the model. The view represents the parts of the application that handle the display of data. This might be HTML, for example. And the controller then handles the interaction between the view and the model, including handling user input. If we look at the dependencies between these components, we see that both controller and view depend on the model, and the controller also depends on the view. That's one of the key benefits of this separation. In other words, the controller chooses the view to display to the user and provides it with any model data it requires. But with all this talk about user interfaces, how does this map to building an API? Well, that view, in API terminology, is the representation of our data or resources. More often than not, these days, that's JSON. And user interaction, well, the user or consumer of an API would typically be another application. So when a request is made by an API consumer, an action on the controller will be triggered. The controller sends any input data, query string parameters for example, to the part of the application responsible for business or data access logic. And it returns a model to the view. That view, in this case, doesn't contain any logic like a Razor or HTML-based view might have, but it's a representation, in JSON for example, of the returned data. And with that, it's time to fire up Visual Studio. In the first demo of this module, we'll add the ASP Net Core Mvc middleware to our application. We're in the startup class, and the first thing we have to do is add a reference to MVC, as the services and middleware are defined in an external dependency. The NuGet dialog is one way of doing this, but I want to show you a pretty nifty feature in Visual Studio, NuGet integration. There's integrated NuGet support in our IDE. If you know the name of the method you need, that's a good way to add the necessary references. I happen to know that to add the MVC framework services, we need to call the add MVC extension method in the configure services method. If we do that, we get a prompt stating that this extension method seems to be available in the Microsoft.ASP.NETCore.MVC package, and we can now add the dependency directly from here. You need to know this in advance. It won't just show up in IntelliSense. Another option, as just said, is using the NuGet dialog to look for the ASP.NET Core NuGet package and add the reference. Let's do that. If you've been working with Visual Studio in the past few years, you know how this works. We right-click on the project and we choose Manage NuGet Packages. The package we need is Microsoft.ASP.NETCore.MVC, and let's install the latest stable release. MVC has been added, the necessary packages have been restored. Back to the startup class, and in configure services, services.addMVC now works. On to the configure method, where we'll have to add the MVC middleware to the request pipeline. For that, we call app.useMVC. We add this to the request pipeline after having added the exception handler middleware to the pipeline. So the exception handler middleware can potentially catch exceptions before handing the request over to MVC, and more importantly, handle exceptions and return the correct response when an exception happens in the MVC related code will write. From this moment on, the MVC middleware will handle HTTP requests. That also means that we can now get rid of the code from the previous module where we threw that exception. We're currently still working in the production environment after the last demo of the previous module. So let's set this back to the development environment so we see developer-friendly errors in case something happens. Let's restart so the new value gets picked up by the web server. And let's run. We get a blank page. Let's have a look at the developer tools. And we see that what we actually got back was a 404 not found status code. So we added the MVC middleware, but it doesn't do anything yet. It can't find any code to execute that will result in a representation of data being returned. There is no code yet, and there's no routing configured to allow for that. So that brings us to the next demo, in which we'll add our first controller to return data, or other resources like cities and points of interest for cities. We're building a city info API. So a cities controller is a good controller to start with. Just as before, we could use a built-in template, but let's not do that, as to better understand what's going on. Just going to add a new class and name it cities controller. Let's start by adding a folder for our controllers and the cities controller class. We want to let this class derive from controller from the Microsoft.ASP.NETCore.MVC namespace. Then we'll need an action that returns data. At this moment, we'll keep this very simple. We want to return JSON as the representation format of our data. For that, we can use the JSON result class. This returns a JSONified version of whatever we pass into the constructor of JSON result. We want to return a list of cities. But we currently don't have a city model class, so let's start with two anonymous objects, giving it an ID and a name. When consuming HTTP services, like our API, to get data back, we should send an HTTP request with HTTP method get to a URI that routes to this method. That's a few different concepts to explain. Let's start with the request itself. Any type of client that consumes an API sends an HTTP request to that API. You can use a browser for that. It's easy enough for GET requests, as that's what the browser sends to a URI. But we'll run into restrictions quite fast when we want to start sending requests to create or update resources. So we'll use Postman for that, as that allows us to create HTTP requests and inspect the responses. So let's open up Postman. In Postman, we can create our requests. As mentioned in the first module, I created collections of all the requests we'll use throughout the course. If you download the exercise files, you can just import them. Let's open the first one. So here we can choose the HTTP method to use for the request and the URI. Later on, we'll also work with headers and the request body, but for now, a GET request with all the defaults will do. Let's run the application and then send this request. The request was sent and we get back a 404 not found result. This is because the MVC framework doesn't know how to map this URI, API/cities, to the action on the controller we just created. It's the principle called routing that handles this. So let's look into that. Routing matches a request URI to a method on a controller. So once we send an HTTP request, the MVC framework parses the URI and tries to map it to one of our controller deriving controllers and the corresponding method on that controller. There's two ways it can do this: convention-based or attribute-based. Let's look at an example of convention-based routing. For this, we have to configure these conventions. We can do that by passing in these routing conventions to the useMVC extension method. An example can be seen on screen. This would map the URI cities/index to the index method on a controller named citiesController. But these types of convention-based mappings are typically used when you're using the MVC framework to build a web application with HTML returning views. For APIs, the ASP Net Core team recommends not using convention-based routing, but attribute-based routing instead. Attribute-based routing, as the name implies, allows us to use attributes at controller and action level. We provide these with an optional template, and through that template, a URI is matched to a specific action on a controller. For this, we use a variety of attributes, depending on the HTTP method you want to match. Let's have a look at the most common ones for the functionality a typical API would want to expose: reading, creating, updating, and deleting resources. First up, reading resources. The correct HTTP method for this is GET. In code, we use the HTTP GET attribute on the action that contains the code to read and return the resource. A sample URI would be API/cities for a list of cities, and API/cities/1 for city with ID 1. Then there's creating a resource. Post is used for this, signified by the HTTP post attribute, also at action level. In the action, the code to create a resource should reside. A sample URI is API/cities to create a city. For updating resources, two options are available. The first one is put, which should be used for full updates. All fields of the resource should be overwritten or set to their default values. The HTTP put method is used at action level, and a put request to API/cities/1 would update the city with ID 1. But you don't always want to fully update the resource. In fact, more often than not, you'll need partial updates to update only one or two fields instead of all of them. That's what a patch action is for, signified by the HTTP patch attribute. A sample URI is the same as for put, API/cities/1 to partially update the city with ID 1. The last of the common HTTP methods is the delete method, to delete a resource. The HTTP delete attribute should adorn the action that deletes the resource. A sample URI is, again, API/cities/1 to delete a city with ID 1. And lastly, there's a special attribute that doesn't match to a specific HTTP method, the route attribute. This is used at controller level. The provided template will prefix all templates of the action level attributes. For example, we see that all our sample URIs start with API/cities. The route attribute could be used at controller level with API/cities as its template value. Like that, we don't have to provide that value in the templates of all the action level attributes. So far for the theory. Now let's have a look at how we can use these. In this module, we'll look into the route and HTTP GET attributes, and we'll encounter the other ones further on in the course. We know we want to respond to a GET request, so let's use the GET attribute. We want this controller action to be executed when we send the request to API/cities. So that's what we pass in as the routing template. Let's build and run. And let's send the request to API/cities via Postman. And this time we get back our 2 cities. So that's nice. We've just created our first API action that actually works. Let's go back to our controller. A controller typically contains other actions, for example, to get a single city, or maybe to create or update one. How these are consumed should be consistent, i.e. we want to consume all our resources by starting with API. And all the resources in this controller start with /cities. We can use the route attribute at controller level for this. So we only have to define this once, and not on each action. Now, the template we pass in contains the plural noun cities. And that's actually the prefix of the controller class name. We can refer to that by putting controller in straight brackets in the template. That will then match the route API/cities to the cities controller. But to be honest, I'm not a big fan of that approach. If we were to have a refactoring of our code later on and rename the controller class, the URI to our cities resource would automatically change as well. This can be considered an advantage for websites, but for APIs it's more of a disadvantage in my opinion, as a resource URI should remain the same, regardless of what the underlying class is named. That's of no importance to the consumer of the API. But that's just my opinion. You're obviously free to disregard this if you want. Let's change it back to API/cities and let's give this a try. Let's send the request again, and there we go. But we're still just returning some JSON directly from anonymous objects. That isn't necessarily a realistic scenario. In most architectures, you'd work with model classes, POCOs or DTOs, that are then serialized to JSON. Let's improve on our architecture in the next demo. So in this demo, we'll get rid of returning JSON directly. Instead, we'll create model classes. Let's start by adding a models folder and one class, CityDTO. Let's give it an ID, a name, and a description. There's an important distinction I want to make here. Maybe we're running a bit ahead of ourselves, but it's quite important. What is returned from or accepted by an API is not the same as the entities used by the underlying data store. Currently, we're going to be working with in-memory data, as we are focusing on the API itself. So the in-memory data store will simply work on these DTO classes we are now creating. But later in the course, we'll add Entity Framework Core to the mix. The entity classes that will work on will be different from these classes. For example, a city DTO might contain calculated fields, like number of points of interest. A person DTO class might contain a full name property, which is a concatenation of first name and last name. These are fields that aren't saved as such in a database. They're calculated on the go and won't be part of the city entity class. And the other way around exists as well. In the next module, we'll learn how to create resources. The model accepted by such a method doesn't contain an ID for a city, as it will be the responsibility of the underlying store to create that. So that'll be another class as well. It won't be the city entity class we'll use with Entity Framework. Anyway, let's continue. We'll need some data to return, so for now, let's add an in-memory data store containing a list of cities. We'll change this out for a persistent database store once we learn about Entity Framework Core. Let's add a new class, Cities Data Store. Let's give it a property, cities, a list of city DTO. And let's copy paste in a bit of code to initialize the dummy data. By the way, little piece of trivia, Antwerp in Belgium is where I live, and one of the symbols of our city really is a big cathedral that was never finished. And it was supposed to have 2 towers and look a bit like the Notre Dame in Paris, as you can see on the pictures here. But the city ran out of money. That may or may not say something about this city. But anyway, let's ensure we have a static property on our city's data store, and let's name that current. It returns an instance of city's data store. This makes sure we can keep working on the same data as long as we don't restart. The syntax you see here is new to C#6. It's the auto property initializer syntax. This allows assignment of properties directly within their declaration. For read-only properties, like this one, it makes sure the property is immutable. Okay, back to our controller. We can now switch out the code we have here by getting the cities from the current city store. And let's give this a try. Our GET request to API/cities now returns the 3 cities from our cities data store. And while we're at it, we can continue with implementing an action to return a single city. Let's add a new action, getCity. Let's decorate it with the HTTP GET attribute. The URI to this resource is API/cities, followed by the ID of the city we want to get. To work with parameters in routing templates, curly brackets are used. Now, as API/cities is part of the route template for our controller, we can just use ID between curly brackets as a parameter for the GET attribute. That ID parameter, that's an integer, and it should be in the parameter list of the action. This ID parameter will automatically be set to the ID from the URI. And let's look for the city with that ID and return a JSON result with the city in JSON format in the response body. Let's build, run, and fire up Postman. And let's try getting a city by appending the ID to the URI. If we pass in ID 1, we get back New York City. And if we pass in another ID, we get back the matching city. But what would happen if we try to send a GET request to an unexisting resource? For example, API/people. We get back a 404 not found, so that's good. And if you remember from the previous module, we got back a 500 internal server error when we threw an exception. These are HTTP status codes, in this case automatically returned by the framework. Yet if we try and get a city that doesn't exist but lives at a URI that can be routed to an action, like API cities 5, we get back a 200 OK status code with a null result. The framework doesn't automatically return a 404 because our URI can be routed. But null isn't the correct result. If a city is not found, we'd expect a 404 not found status code. We should be able to check for cases like this, which our code currently doesn't. And we should correctly return status codes. Let's learn why this is so important. We already learned that to consume the API, the consumer sends an HTTP request using an HTTP method like GET. He then gets back an HTTP response. This response contains a status code. And it's really important to get these right, because these status codes are the only thing a consumer of the API, like a client-side web app, can inspect to know if request worked out as expected. Or if something went wrong, and if something went wrong, whether it's the fault of the consumer or the fault of the API itself. Imagine you're sending back a 200 OK status code for each and every request. The consumer would assume his request worked out as expected, even if it went wrong. And imagine that when something goes wrong, we'd only send back a 500 internal server error. The consumer would never know if it's his fault something went wrong, for example, sending a GET request for a city that doesn't exist, meaning he can correct it and try the request again, or if it's the server's responsibility, in which case the client shouldn't try and correct the mistake, because the mistake isn't his. There's a lot of status codes, and an API doesn't necessarily have to support all of them. But let's look into a few common ones. There's 5 levels of status codes. Level 100 status codes are informational and weren't part of the HTTP 1.0 standard. These are currently not used by APIs. The level 200 codes mean the request went well. The most common ones are 200 for a successful GET request, 201 for a successful request that resulted in the creation of a new resource, and 204 for the successful request that shouldn't return anything, like a delete. Level 300 status codes are used for redirection. For example, to tell a search engine a page has permanently moved. Most APIs don't have need for these. Then there's the status codes that tell the consumer he did something wrong. Level 400, client error. 400 means bad request. The request you, as a consumer of the API, sent to the server is wrong. For example, the JSON the consumer provided can't be parsed. 401 unauthorized means that no or invalid authentication details were provided. And 403 forbidden means that authentication succeeded, but the authenticated user does not have access to the requested resource. 404 not found means that the requested resource doesn't exist, and 409 is used for conflicts. For example, an edit conflict between 2 simultaneous updates. And lastly, there's level 500, server errors. Often, only the 500 internal server error is supported. This means that the server made a mistake and the client can't do anything about it other than trying again later. Let's see how we can implement this. In this demo, we'll learn how to return correct status codes with our responses. We're back in our cities controller and we need to return a response with a specific status code. Currently, we're still returning a JSON result here. Let's have a look at JSON result. If we look at the definition, we see that JSON result is an action result, which formats the given object as JSON. An action result, well, that's a default implementation of iActionResult. iActionResult defines a contract that represents the result of an action method. But this JSON result, well, that's not always what we want to return. First of all, APIs don't necessarily work with JSON. They should return what the consumer asks in the accept header of the request if that format is supported. But more importantly, it's not always simply a bunch of JSON you want to return. We just learned about the importance of status codes. We need to be able to return the response with a specific status code. Now, this is possible with JSON result as well.